the infusion of computing in the world around us. And that includes, of course, our PCs, our phones, but also the embedded computing in buildings, in factories, in cities, in oil wells. What we mean by setting that worldview is that we strive to provide a platform in Azure as the world's computer that is consistent across large-scale public cloud data centers all the way to the smallest of IoT devices as much as possible. We focus on four primary pillars: productivity, trust, hybrid, and intelligence. And with each one of these, we've got differentiated solutions, and the combination makes us truly differentiated. Hi everyone, my name is Russinovich. I'm Chief Technology Officer of Microsoft Azure. What I'm going to spend with you today is taking a look at Azure, which we consider the world's computer. Where does the term world's computer come from? What does it mean? If we go back a couple years, Satya introduced Microsoft's worldview, Intelligent Cloud, Intelligent Edge, where we're looking beyond just large-scale public cloud data centers to edge computing, the infusion of computing in the world around us. And that includes, of course, our PCs, our phones, but also the embedded computing in buildings, in factories, in cities, in oil wells. What we mean by setting that worldview is that we strive to provide a platform in Azure as the world's computer that is consistent across large-scale public cloud data centers all the way to the smallest of IoT devices as much as possible. That consistency including management, security, identity, monitoring, management, application models, and programming models. Before I talk more about how we're fulfilling that vision of Intelligent Cloud, Intelligent Edge, I'd like to spend a few minutes talking about the ways that Azure differentiates from other cloud providers. We focus on four primary pillars: productivity, trust, hybrid, and intelligence. And with each one of these, we've got differentiated solutions, and the combination makes us truly differentiated. Let's spend just a minute or two on each one of these, where I'm going to highlight examples of how we differentiate. The first being productivity, where more and more productivity for enterprises means open source technologies, whether it's Linux at the foundation or leveraging an open source container orchestrator like Kubernetes. Azure's been focused on supporting open source for many years now, and we've got a portfolio of support for open source, including multiple Linux distributions from Canonical, Red Hat, SUSE, and more, all the way up to higher level frameworks and languages, including some truly unique partnerships with open source community, like our partnership with Red Hat, where we jointly operate Azure Red Hat OpenShift, a Kubernetes service that's built on our own Kubernetes service, Azure Kubernetes Service, or AKS, to Databricks, the company behind Spark, a popular framework for machine learning and data analytics, where we operate a service jointly with them, Microsoft Azure Databricks, where you get the best notebook and Spark experience on any public cloud. But Microsoft's focus on productivity also goes into tooling. Microsoft's been focused on tooling from its very birth as a company. And today, our support for tooling and development extends all the way from the development, from the programmer entering their code in an IDE with Visual Studio Code, the #1 IDE on the planet now, fully open source, in fact, the #1 most active open source project on the planet, and now adopted by companies that were never even before interested in anything from Microsoft, to Azure DevOps, the world's #1 CI/CD platform as a service, which provides you the ability to create build pipelines, integration pipelines, as well as release pipelines, to GitHub, an acquisition we made about a year ago, the place where open source developers collaborate, home to now more than 40 million open source repositories and 44 million active developers. Microsoft making GitHub do more of what it does best, which is open source collaboration. Just in the last year, we've made a number of enhancements to GitHub, like GitHub Actions, which allows you to create CI/CD workflows on top of your GitHub repositories. If we turn our attention to trust, Microsoft's got a long history of trust and understanding enterprise requirements in security and compliance. Azure demonstrates that its certification coverage, the most of any public cloud, over 90 certifications spanning global, US government, industry standards, and regional certifications. Microsoft Azure also has the deepest coverage in certifications, where deep means the number of services that meet these certifications. Each of these certifications represents hundreds of security controls. They're a reflection of the fact that we produce evidence that we adhere to them, that give customers and regulators the trust to place their workloads and data in Microsoft Azure. But that focus on security controls extends to the support for keeping your environment and our environment secure. Microsoft follows a first party equals third party principle for security. One of the tools we use to secure our infrastructure is Azure Security Center, which we make available to customers. Azure Security Center will look across your Azure resources, notify you of when you've got security gaps, and even make recommendations for how to address them. For many of them, you could address the recommendations right from in the Azure Security Center portal. For example, if you're missing just-in-time access control on your virtual machines, you can simply select the toggle to turn them on to your virtual machines and mitigate them immediately. And what's even better is you, with the guidance of Security Center Secure Score, are guided to prioritize the security enhancements, the gaps that you close, where Secure Score ratings are provided for each mitigation so that you can go after the ones that boost your secure score the highest, and that also gives you the ability to track over time how you're improving the security of your service. Now, turning our attention to hybrid, if you take a look at Microsoft's focus on hybrid, it's been there from the very start because we've understood that enterprises, as they move to the cloud, whether it's fast or slow, want a consistent experience with their on-premises resources and their cloud resources. We've got many foundational capabilities that support this hybrid posture, including, for example, Azure Active Directory integration federation, so that with Active Directory on premises, so that you as an enterprise, if you're using Active Directory, can have your users sign on to your local resources and have single sign-on to cloud resources like Azure. And then finally, intelligence. The intelligence cloud, intelligent edge is machine learning and AI, and Microsoft's been working in this area for decades now, primarily in support of our Bing search engine. When you use Bing, you're looking at images, you're translating text from speech. A lot of the breakthroughs that we have in these areas are driven by our Microsoft research labs around the world, including in China. You can see our Chinese Shanghai and Beijing labs are responsible for some of the key breakthroughs that we've made on machine translation, human parity, going from Chinese to English and Chinese and English to Chinese better than humans can do it. Those innovations flow into our cognitive services, our APIs produced that serve up these models. Now that I've gotten a little bit, given you a little flavor for some of the differentiation, let's dive right into what's underneath the hood in Azure. So you can see that the cloud is rapidly evolving, and we're in the deepest wave of innovation that IT has seen ever because of this strong vertical integration from the software all the way down to the hardware. Now, speaking of hardware, the cloud starts with the data center hardware. And let's take a look at some of our data centers. First of all, Azure is a global cloud, truly the world's computer in the sense that we've got more and more regions, 58 and counting, all around the world, multiple in China as we continue to expand. And when we talk about those regions, we talk about them in the context of geographies. Geography being a boundary where customers are happy having their data reside. China being one, for example, geography. Within those geographies, we'll create two regions. One region that will have availability zones, and another one that can serve as a disaster recovery site. In some cases, depending on the size of the regions, we might have all regions, or the geo, all regions with availability zones. But with availability zones, what you get is the ability to tolerate localized failures, failure like a flood in the data center, or even a flood in the local region. A flood that won't impact more than one of those availability zones, where the availability zones are made up of discrete data centers that are separated typically by kilometers. They're close enough, though, that you can replicate data synchronously so that if one availability zone is down, for example, there's a flood or fire in the data center, the other ones continue to operate, and your services then continue to operate. That second region is a region pair, and it serves as a disaster recovery target. You may be wondering, what about impact on climate change with all of those servers pumping out carbon? Microsoft's commitment to the environment spans not just our data centers, but the whole company and everything we do. So we're one of the largest purchasers of renewable energy, whether it's water or wind or solar. We've made some of the largest deals in corporate history to procure renewable energy. But we've got a commitment that goes to not just ensuring that we're that we're offsetting our carbon production, but that we're actually completely eliminating it. Not just eliminating it now as we go forward, but also going back in time to pull out from the atmosphere all of the carbon Microsoft's ever put into it. This was a commitment, you can see Satya with Amy and Brad Smith, our president, that we made to go and become by the year 2050 net carbon zero, meaning we'll have pulled out of the atmosphere more carbon than Microsoft's put in since its founding in 1975, not just in terms of data centers, but also our offices, our employee travel, and the suppliers that produce the products that we then put together into data centers or products like Surface Books. Now let's take a look at our servers. You can see that the Gen 6 servers that we're deploying in our mainstream fleet today, we expect to even be bringing and building larger servers because our customers are creating ever yet bigger SAP workload deployments that they want to bring to the public cloud. One of the places we're looking is to meet this trend of CPUs and GPUs, which are drawing ever increasing amounts of energy. These are technologies that we're working on and we expect to see in production in the not too distant future. Innovations that for an enterprise would be very difficult to go fund or deploy, but we're doing it in conjunction with the design of our servers, and so we can very quickly bring these technologies out and make them available. Now, let's take a look at Azure networking. And networking spans everything from the physical WAN to all of the software-defined services like DDoS protection, VPN, virtual networks, firewalls, out to connections with the outside world, whether that's the edge or enterprise networks through ExpressRoute and ExpressRoute Direct, which support up to 100 gigabits bandwidth that goes directly from an enterprise network into Azure's network. And that network spans the world. 130,000 kilometers of cabling, 160 edge sites, 500 network partners and growing. Network that we control our own from end to end. So when traffic enters our network and goes out across the world to another region, it stays completely on our dark fiber. One of the innovations we're working on in the networking is making containers. We're also making innovations in making containers operate better, not just in networking, but also have higher performance. One of the challenges with large containers is that if you take a look inside of a container, they're made up of images that are layered on top of each other. And before you can launch or start the code that's in a container, you need to load all those images. And if for a large container, that can take a long time. With something called Project Teleport, we're making it so that those containers can start in a fraction of the time, because instead of loading all of the containers, we just simply mount those images on file shares. And once they're mounted as file shares, we can start executing without having to pull all the data across from the servers. They get faulted in on demand. You can see dramatic differences. So that brings me to the conclusion of the talk. I hope you found this interesting. I hope it gave you some insight into Azure's differentiation, hybrid, trusted, productive, intelligent, as well as a look underneath the hood at our data center, servers, compute, network, and storage, including some of the innovations that we've been working on. Thanks very much, and I hope to see you on Azure.